Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on Conditional Probability. If you need any extra help on Conditional Probability, if you go to Corbettmaths and go to video number 247, there's a dedicated video tutorial there on Conditional Probability. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so let's have a look at our first question. Our first question says there's 10 sweets in a bag, and 3 of the sweets are lemon flavoured and 7 are strawberry flavoured, and we're told that 2 sweets are selected at random. And we've been asked to calculate the probability that A, both sweets are strawberry flavoured. So we want to find the probability of a strawberry sweet and another strawberry sweet, so the probability of a strawberry and a strawberry. So in terms of this, altogether, if we have a look at the bag, there's 10 sweets. 3 of them are lemon, so we've got a lemon, a lemon, and a lemon, and 7 are strawberry, so strawberry, 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 and strawberry. So we've got 10 sweets altogether, and the probability that the first sweet picked at random is a strawberry sweet would be 7 out of 10, because there's 7 strawberry sweets out of the 10 of them. So the probability that the first sweet chosen from the bag is a strawberry sweet would be 7/10, so 7 out of 10. Then, if we want to find the probability of the second one being a strawberry sweet, well, one of the strawberry sweets has been taken out of the bag. So now there's 9 sweets in the bag, and there's 1, 2, 3, 4, 5, 6 strawberry sweets. So the probability of the second one being a strawberry sweet will now be 6/9. So we're going to multiply that by 6/9. Because to find the probability of a strawberry sweet and a strawberry sweet, we times the two probabilities together. So we're going to do 7/10 multiplied by 6/9. And when we do that, 7 times 6 is 42, and 10 times 9 is 90. So the probability of getting a strawberry sweet and a strawberry sweet will be 42/90. And then if we wanted to, we could cancel down if we wanted to. You don't actually have to. You could leave your answer like that because the question didn't say to simplify. But I'm going to simplify it anyway. Both of those numbers are divisible by 6. So if we divide the numerator by 6, we get 7. And if we divide the denominator by 6, we get 15. So that means the probability that both sweets would be strawberry flavoured would be 7/15. And that's it. Okay, let's have a look at our next part, part B. Okay, then if we have a look at part B, we've been asked to calculate the probability that one sweet is lemon flavoured and one sweet is strawberry flavoured. So that would be the probability of getting a lemon and a strawberry sweet, or the probability of getting a strawberry and a lemon sweet. Because there would be the two options. We'd either have a lemon and then a strawberry, or a strawberry and then a lemon. And then you would have one sweet that's lemon flavoured and one sweet that's strawberry flavoured. Okay, so let's start off by looking at the probability of a lemon and then a strawberry. So remember we had 3 lemon sweets, so lemon, 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 and we had 7 strawberry sweets, strawberry, 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 and strawberry. So we had 10 sweets altogether. And the probability that the first one picked at random would be a lemon sweet would be 3 out of 10, so 3/10, so 3/10. And then we're going to multiply that by the probability of the second one being a strawberry sweet. So one of the lemon sweets has been taken at random. So now we're left with 9 sweets. So we'll have a 9 on the denominator. And we want to find the probability that the second sweet is a strawberry sweet. So there's 1, 2, 3, 4, 5, 6, 7 strawberry sweets. So if the first sweet that's taken out is a lemon sweet, the probability that the second one's going to be a strawberry sweet would be 7/9. So if we multiply those together, 3 times 7 is 21, and 10 times 9 is 90. So it means the probability of getting a lemon sweet and then a strawberry sweet would be 21/90. Now let's have a look at the probability of getting a strawberry sweet and then a lemon sweet. So if we put the sweets back in the bag, let's put that lemon sweet back in the bag there. So it's back in the bag of uncrossed it out, so it's there now. So we want to find the probability of getting a strawberry sweet. So in the bag at the beginning, there's 10 sweets, 7 are strawberry flavoured, so that's going to be 7 out of 10. So this is the probability for the first sweet being a strawberry sweet would be 7/10. Then if that sweet's taken out, in terms of the second sweet being a lemon sweet, there's now 3 out of 9. So the probability of the second sweet being a lemon sweet would be 3/9. And then if we multiply them together, 7 times 3 is 21, and 10 times 9 is 90. So that's fantastic. We now know the probability of getting a lemon sweet and then a strawberry sweet. And we also know the probability of getting a strawberry sweet and then a lemon sweet. So then if we add those two probabilities together, because it's either that option or that option, if we add them together, that tells the probability of getting 1 lemon and 1 strawberry sweet in either order. So 21/90 plus 21/90 would be 42/90. So the probability of getting 1 lemon sweet and 1 strawberry sweet would be 42/90. And again, we haven't been asked to, but we could cancel this down. Both of those numbers are divisible by 6. 42 divided by 6 is 7, and 90 divided by 6 is 15 again. So the probability of getting 1 sweet that's lemon flavoured and 1 sweet that's strawberry flavoured would be 7/15. And that's it. Okay, let's look at our next question, question number 2. Question number 2 says that Luca has 5 pens in his pencil case. 3 of the pens are blue, so we've got a blue, a blue, and a blue. And 2 of the pens are red, so a red and a red. So there's 5 pens, a blue, a blue, a blue, a red, and a red. And Luca takes 2 pens at random from his pencil case. And we've been asked to find the probability that Luca takes 2 pens that are the same colour. So in terms of the outcomes that would work for that, that would be either the probability of a blue and a blue, or the probability of a red and a red. So let's start by looking at the probability of Luca picking a blue pen and then another blue pen. So the probability that the first pen picked at random is blue would be 3 out of 5. So that'll be 3/5. And then in terms of the second pen, well, once one of the blue pens has been taken out, there's 4 pens left. In terms of the second one being blue, well, that's now going to be 2 out of 4, so 2/4. So if we do 3/5 times 2/4, that'll tell us the probability of getting a blue pen and then another blue pen. So 3 times 2 is 6, and 5 times 4 is 20, so that'll be 6/20. So the probability that Luca picks a blue pen and then another blue pen will be 6/20. Now we can cancel that down, but I'm not going to yet, because quite often with these probability questions, when you're adding together the options at the end, it can be quite useful if you haven't cancelled them down, and then if you do want to cancel them down, to cancel it down at the very end. Okay, and then we've now got the probability of a red pen and another red pen. So that would be, if we put the pens back in the pencil case, we've got a blue, a blue, a blue, a red, and a red. So we want to find the probability of getting a red pen and then another red pen. So there's 5 pens in the pencil case altogether to begin with. The probability that the first one is red is 2 out of 5, so 2/5. And then if we take out that red pen, we're left with 4 pens in the pencil case and one of them's red. So we're then going to multiply that by 1/4, 1 out of the 4. So we've got the probability that the first pen is red would be 2/5, and the probability that the second pen is red would be 1/4. And then if we times them together, that'll tell us the probability of getting a red and then another red. So 2 times 1 is 2, and 5 times 4 is 20. So that'll be 2/20. And now that's fantastic, because we now know the probability that Luca gets 2 blue pens, and also the probability that Luca picks 2 red pens. So if we add them together, because it's either this option or this option, that'll tell us the probability that Luca picks 2 pens that are the same colour. So 6/20 plus 2/20 would be 8/20. And this can be cancelled down. Both of those numbers are divisible by 4. So 8 divided by 4 is equal to 2. And 20 divided by 4 is equal to 5. So that'll be 2/5. And that's it. Okay, let's look at our next question, question number 3. So question number 3 says there's 12 tiles in a bag. And we've got these tiles, Corbettmaths, so Corbettmaths. And Jim's going to choose 2 of the tiles at random from the bag. And the question says, what's the probability that the 2 tiles are the same letter? So that means he's going to take 2 tiles from the bag, and we want to find the probability that they've got the same letter on them. So it can't be a C and another C, because there's only one C in the bag. So that means that he can't take a C and then another C. He can't take an O and another O. He can't take an R and another R, or a B and another B. He couldn't take an E and then another E. He could take a T. He could take a T and another T, because there's more than one T in the bag. He can't do M, he can't do A, H, or S. So T is the only letter that he can get a T and then another T. So we want to find the probability that Jim takes a T and then another T. So here, the probability that the first letter chosen at random is a T. Well, so there's 12 tiles altogether, and there's 1, 2, 3 T's. So the probability that the first letter chosen at random is a T would be 3/12. And then we're going to multiply that by the probability that the second one's going to be a T. So if one of the T's is chosen at random, so one of the T's is coming out of the bag, I'm just choosing that one, it could be any of them. There's now 11 tiles in the bag, and we want to find the probability that the next one's a T. Well, it's going to be 2 out of 11, so 2/11. And then if we just multiply them together, we'll find the probability of finding a T and then another T. So 3 times 2 is equal to 6, and 12 times 11 is 132. So the probability that Jim chooses a T and another T would be 6/132. That can be cancelled down. We can divide both the numerator and denominator by 6. And if we do that, we get, well, 6 divided by 6 is equal to 1. And 132 divided by 6 is equal to 22. So the answer would be 1/22. And that's it. Now the question didn't ask us to cancel down, so we could have left the answer as 6/132. Or even you could half both of them to get 3/66, and then divide by 3 to get 1/22. And that's it. Okay, let's look at our next question, question number 4. So question number 4 says that Alex and Beth were 2 of the 6 finalists in an art competition, and the 2 best selected finalists will win a prize. So 2 out of the 6 finalists will win a prize. And the question is, find the probability that Alex and Beth are selected. There's a couple of different ways you can approach this question. One approach is say, well, that could be the probability of getting Alex and then Beth. and then the probability of Beth and then Alex, and then we could add them together. So that's one approach. Another approach would just be to consider the two girls and say the probability of one of those is selected and then the other one being selected. So I'm going to do the two different approaches. So let's start off with this one, the probability of finding Alex and then Beth and then Beth and then Alex. So in terms of Alex being selected first, so the 6 finalists all together, there's one of them that's Alex, that's going to be 1 out of 6. Then if Alex is chosen, then probably the next one picked as Beth would be 1 out of 5, so 1 over 5. And then if we times them together, that would be the probability of Alex and then Beth being selected. So 1 times 1 is equal to 1, and 6 times 5 is equal to 30. So the probability of Alex coming first and then Beth coming second would be 1/30. And then in terms of Beth and then Alex, the probability that Beth is selected would be 1 over 6. That's the chance of her coming first. And then in terms of Alex coming second would be, well, because Beth's been selected, there's only 5 left. And that means it's going to be Alex, which would be 1 out of 5. And then if we times them together, 1 times 1 is equal to 1, and 6 times 5 is equal to 30. So that's fantastic. We've now found the probability of Alex and then Beth being selected, and also the probability of Beth and then Alex being selected. So if we want to find either one of those, we could add them together. So that would be 2 over 30, or 1/15. So the probability that Alex and Beth were selected would be 1 over 15, and that's it. So that's one approach. Another approach would be to say, well, if we've got these two people that we're interested in, the probability that one of them is selected in terms of the first person to win a prize would be 2 over 6. And then if that person's been selected, the probability that the other one that we're interested in would be 1 out of the 5, because one of them that we're interested in has been selected first. So it'd be 1 out of 5. And then if we times them together, we get 2 over 30. And if we cancel that, then that'll be 1/15. And that's it. Okay, let's look at our next question, question number 5. Okay, so question number 5 says there's 5 counters in a bag. So we've got a pink counter, a green, a yellow, and a yellow. And that's what the question says. And then we're told that 2 counters are selected without replacement. So one's taken out, and then another one's taken out without putting the first one back in. And the question says, find the probability that both counters are yellow. So we want to find the probability of a yellow and then another yellow. And one thing to notice there is it says that the 2 counters selected without replacement. You'll see that a lot in conditional probability questions, because that means without replacement means the probabilities will change after the first one's taken out. So that's why it's conditional probability. Okay, so the probability of a yellow and then another yellow. Well, altogether there's 5 counters and there's 2 yellows. So the probability of the first one being selected is yellow will be 2 out of 5, so 2/5. Then if one of those yellow counters has come out, the probability of the next one being selected as yellow will be 1 out of 4, so 1/4. And then if we times them together, 2/5 times 1/4, 2 times 1 is equal to 2, and 5 times 4 is equal to 20. So that'll be 2 out of 20, and if we cancel that down, that'll be 1/10. So the probability that 2 yellow counters are selected would be 1/10. Okay, let's look at our next question, question number 6. Okay, so question number 6 says, a bag contains 8 marbles. 4 of the marbles are red, 3 of the marbles are yellow, and 1 marble is black. And Mahika takes 2 marbles from the bag at random. And the question says, find the probability that she takes marbles that are different colours. So because they're different colours, what I'm going to do is I'm actually going to find the probability that the counters are the same colour. So rather than saying, well, if they're different colours, then it could be red and then yellow, red and then black, yellow and then red, yellow and then black, black and then red, and black and then yellow, and having 6 different options. What I'm going to do is I'm going to consider the probability that the counters are the same colour. So I'm going to find the probability of a red and a red, a yellow and a yellow, and a black and a black. And then if I add them together and take that away from 1, what's left will be the probability that they're different colours, because obviously the probability that they're the same colour plus the probability that the different colours will have to add together to be 1. So 1 minus the probability that they're the same would be equal to the probability that they're different. And that's quite a useful technique. So rather than going through all the options of different colours, so red and yellow, red and black and so on, we could just find the probability that they're the same colour and then take that away from 1, and that'll tell us the probability that they're different colours. Okay, so one thing to notice here is that Mahika's taken 2 marbles from the bag. So she could get a red and a red, because there's 4 red marbles out of 8, and she could take 1 out and then get another one. She could get a yellow and a yellow, because there's 3 yellow marbles, and she can take a yellow one out and then another yellow one out. But one thing I've noticed here is that Mahika can't get a black and a black marble, because there's only 1 black marble in the bag, and if she's taken 1 out, she can't get another one to be black. So that means that we're looking for the probability of a red and a red. We're going to find the probability of a yellow and a yellow. We'll add them together. That's the probability that they're the same, and then we can do 1 take away that probability, and that'll tell us the probability that they're different colours. So let's do that. The probability of a red and a red. So there's 8 marbles, and there's 4 that are red, so the probability that the first one being picked at random as red will be 4/8, 4 out of 8. Then, if we take one of those red marbles out, there will then be 3 red marbles left, 3 yellow and 1 black, so there's 7 left now. The probability that the next one's going to be red will be 3 out of 7, so 3 7s. And then if we times them together, 4 times 3 is equal to 12, and 8 times 7 is 56. So the probability that Mahika gets a red and a red would be 12/56. Okay, now let's find the probability of a yellow and then a yellow. So there's 8 marbles. Let's put them all back in. There's 8 marbles. 3 of them are yellow, so the probability that the first one being picked at random as yellow will be 3/8. Then, if one of those yellow marbles is taken out of the bag, there'll then be 2 left, and there'll be 7 altogether. So the probability that the next one that'll be yellow will be 2 out of 7, so 2 7s. So if we do 3/8 times 2 7s, that'll tell us the probability of a yellow and then another yellow. 3 times 2 is equal to 6, and 8 times 7 is equal to 56. So the probability of getting a yellow and then another yellow will be 6/56. Then, if we add them two together, that'll tell us the probability that the 2 marbles are the same colour. So 12/56 plus 6/56 would be 18/56. So that's fantastic. We now know the probability that the marbles are the same colour is 18/56. If we take that away from 1, so we do 1 minus 18/56 on our calculator, we'll find the probability that they're different to each other. And that's going to be equal to 38/56. Or if you've done it on the calculator, it may cancel it down for you straight away, and that'd be equal to 19/28. So the probability that the marbles are different colours, so the probability that Mahika takes marbles that are different colours would be 19/28. And that's it. So just to recap, we consider the probabilities that they're the same as each other. So the probability of a red and a red and a yellow and a yellow, but we can't do a black and a black. So we found those two, we added them together. So that's the probability that the marbles are the same colour, and that's equal to 9/28 or 18/56. And if you take that away from 1, that tells us the probability that they're different two colours to each other, and that's equal to 38/56 or 19/28. And that's it. Okay, let's look at our next question, question number 7. Okay, so let's have a look at our next question, question number 7. So question number 7 says a bag contains a total of 60 yellow and blue counters. So we know there's 60 counters altogether and they're just yellow and blue. And 80% of the counters are yellow. So we can work out 80% of 60 and that'd be how many yellow counters there are. And then the rest will be blue. Archie picks 2 counters from the bag at random without replacement. So he's going to take 2 counters out of the bag. He's going to take one out. He's not going to put it back in, and then he's going to take another one out. And the question says, find the probability that Archie chooses 2 blue counters. Okay, so in this question, the first thing I'm going to do is work out how many yellow and how many blue counters there are. So let's work out 80% of 60. So 10% of 60 is equal to 6. And then if we want to find 80% of 60, we just need to times that 6 by 8 because it's 8 lots of 10%. So 8 times 6 is equal to 48. So there's 48 yellow counters, and that means the rest will be blue. So that means that if there's 60 altogether, if we do 60, take away 48, that's equal to 12. So it means there's 12 blue counters. So there's 12 blue counters in that bag. Now the question says find the probability that Archie chooses 2 blue counters. So we want to find the probability of a blue and then another blue. So the probability of the first counter being blue will be 12 out of 60, so 12/60ths. And then we're going to multiply that by the probability of the second one being blue. Well, because one of the blue counters has been taken out, there's only going to be 11 blue counters left in the bag. And there's not going to be 60 counters in the bag anymore, there's going to be 59. So the probability that the second one being blue will be 11/59ths. And then if we multiply 12/60ths by 11/59ths, that'll tell us the probability that Archie chooses 2 blue counters. So let's work that out. And that's equal to, it's a calculator question, so I've typed that into my calculator and I've got an answer of 11/295ths. So the probability that Archie chooses 2 blue counters will be 11 out of 295. And that's it. So the answer is 11/295ths. Okay, let's look at our next question, question number 8. And it's a non-calculator question, so I'm just putting down my calculator reluctantly. Okay, so the question says there's 5 white socks and 1 black sock in a drawer. And Lucy's going to pick 2 socks at random from the drawer. So she's going to take out a sock and then another sock. And then the question says, she says the probability of her choosing 2 white socks is 25/36. And the question says, is Lucy correct? And explain your answer. So we want to find the probability of finding 2 white socks. That's going to be the probability of a white and then another white. So the probability of the first sock being white, well, the 6 socks all together in the drawer, because there's 5 white and 1 black, so the 6 socks all together, so it's going to be out of 6. And the probability that the first one will be white will be 5 out of 6, 5, 6, because there's 5 white socks out of the 6 altogether. Now, it says she's going to take 2 socks out at random from the drawer. So she's taking a sock out and then another sock out. So in terms of the second one being white, well, when one of the white socks has been taken out of the drawer, there won't be 5 anymore. There'll be 4 white socks and then 1 black sock. So the probability that the second one will be white will be 4/5, because there's 5 socks altogether. 4 of them are white, so it's going to be 4/5. So that means if we want to find the probability of a white sock and then another white sock, we're going to do 5/6 multiplied by 4/5. And let's work that out and see what it is. And then we'll be able to see if Lucy's right or not. So 5 times 4 is equal to 20, and 6 times 5 is equal to 30. So the probability that Lucy picks 2 white socks would be 20/30. And that actually cancels down. That cancels down to 2/3. And that's not 25/36. So the question says, is Lucy correct? Well, the answer is no, she's not correct. And let's explain that. And I've just written no, the correct probability is 2/3. And let's actually see what Lucy's done wrong. So Lucy got an answer of 25/36. Now the question didn't ask us what Lucy's mistake was, but I'm just going to explain it anyway. So in terms of the probabilities here, what Lucy's done is she said the first sock being white will be 5/6, because there was 5 white socks out of the 6 socks altogether. And then in terms of the second sock, she hasn't changed the probability. She's actually put that white sock back in. The question said that Lucy's going to pick 2 socks at random from the drawer, so she's taken out a sock and then taken out another one without replacing it. So that means that the probability should be 4/5 for the second one being white, because there's 4 white out of the 5 socks. But if we consider the fact that Lucy thinks that sock's gone back in, then the probability would be 5/6 again. And if we do 5/6 times 5/6, that'll be 25/36. And that's wrong. So the correct answer should be 20/30 or 2/3. Okay, let's look at our next question, question number 9. Okay, question number 9. Question number 9 says, Guy has got 7 cards, each one's labelled with a number. So we've got these 7 cards and they've got the numbers 1, 2, 3, 3, 4, 5 and 5. And Guy's going to choose 2 cards at random without replacement. So he's going to take a card and then he's going to take another one without putting the first one back. And the question says, calculate the probability that the numbers on the 2 cards will add up to be 6. So let's consider the options that could work. So it could be a 1 and a 5. So we could find the probability of a 1 and a 5. So 1 and a 5. We could then find the probability of a 5 and a 1. They would also add together to be 6. We could find the probability of a 2 and a 4. They would add together to be 6. We could find the probability of a 4 and a 2. They would also add together to be 6. And finally, we could find the probability of a 3 and a 3. So they would be the options that would work. Guy could take out a 1 and a 5, or a 5 and a 1, a 2 and a 4, or 4 and a 2, and finally a 3 and a 3. They're the options that would give us 2 numbers that would add together to be 6. So let's find the probability of each of those and then add them all up, and then that'll be the probability that Guy chooses 2 numbers that add together to be a 6. So let's start off with the probability of a 1 and a 5. So a 1 and a 5. So altogether the 7 cards, let's just count them. 1, 2, 3, 4, 5, 6, 7. Yep, the 7 cards. The probability that the first number is a 1 will be 1 out of 7, 1/7. And then multiply by the probability that the second one is a 5. Well, if that one's been taken out, there'll be 6 cards left. And how many 5s are there? There's 2 5s. So once that one's taken out, the probability that the second card is a 5 will be 2 6s, because there's 6 cards left and 2 of them have got a 5 on them. So 2 6. So if we do 1/7 times 2 6, that'll give us the probability of a 1 and then a 5. So let's work that out. So 1 times 2 is equal to 2, and 7 times 6 is equal to 42. So the probability that Guy chooses a 1 and then a 5 will be 2 out of 42, or I suppose 1 out of 21 if we cancel it down. But it's a non-calculator question, so I tend not to simplify until the very end. Okay, now let's consider the probability that Guy chooses a 5 and then a 1. So if we put that 1 back in. Okay, so in terms of the first card being a 5, well, there's 7 cards altogether, and there's 2 of them with 5s on them. So the probability that the first card chosen at random has a 5 on it will be 2 7s. And then we're going to multiply that by, well, if one of those 5s has been taken out, there's going to be 6 cards left, and one of them's got a 1 5 on it. So the probability that the second card is a 1 will be 1 out of 6. And then if we do 2 7s times 1 6, that'll tell us the probability that Guy chooses a 5 and then a 1. And 2 times 1 is equal to 2, and 7 times 6 is equal to 42. So the probability of Guy choosing a 5 and then a 1 will be 2 out of 42. Okay, now the probability of a 3 and a 3. Well, in terms of the first card being a 3, there's 7 cards. 2 of them have got 3s on it, so probably the first one being a 3 would be 2/7. Then if one of the cards is taken out, there'll be 6 left, and it's going to be a 3 that's taken out, so one of the 3s is taken out. So the probability that the second one's going to be a 3 will be 1 out of 6, because one of those 3s will be taken out. There'll be 6 cards left, and there'll be one 3 to choose from, so it's going to be 1 out of 6. So that's 1/6. Okay, and then if we multiply those together, 2 times 1 is equal to 2, and 7 times 6 is equal to 42. So the probability of Guy choosing a 3 and then another 3 will be 2 out of 42 as well. Okay, now the probability that Guy chooses a 2 and then a 4. So the 7 cards all together, the probability that the first one is a 2 will be 1/7. Then, if that 2 is taken out, the probability that the next card is a 4 would be 1 out of 6, so 1/6. And then if we times those together, 1 times 1 is 1, and 7 times 6 is 42. So the probability of Guy choosing a 2 and then a 4 will be 1 out of 42. And finally, the probability of, I'm just going to write that back out. And then finally, the probability of a 4 and then a 2, well, altogether the 7 cards, one of them's got a 4 on it, so the probability that the first card is a 4 would be 1 out of 7. Then if that card's taken out, there's 6 cards left, and there's one with a 2 on it, so the probability that the second card is a 2 will be 1/6. And then if we times them together, 1 times 1 is equal to 1, and 7 times 6 is equal to 42. So we've now found the probabilities of Guy choosing a 1 and a 5 and a 1, a 3 and a 3, a 2 and a 4, and a 4 and a 2. And they're all the options where the numbers will add together to be 6. If we want to find the probability that the two numbers on the cards will add together to be 6, we just need to add together these probabilities. So let's work that out. So 2/42 plus 2/42 plus 2/42 plus 1/42 plus 1/42. When you add them together, well, all the denominators are the same. So 42 is going to be on the denominator. And let's add together the numerators. 2 plus 2 plus 2 is 6, plus another 1 is 7, plus another 1 is 8. So it's 8 out of 42. And then let's cancel this down. Now the question didn't ask us to cancel it down, so we could just leave our answer like that, 8 out of 42. But if we cancel it down, let's half them both. That's going to be 4 out of 21. And then that's it, 4/21. So the probability the Guy chooses two cards that add together to be 6 will be 4 out of 21. And that's it. Okay, let's look at our next question, question number 10. So question number 10, it says there's 7 vanilla and 2 chocolate cupcakes on a tray. And Ronan takes 2 cupcakes from the tray at random. And the question says find the probability there's at least 1 chocolate cupcake left on the tray. So this question is a bit different in terms of the wording. I just want to read that last sentence again. Find the probability there's at least 1 chocolate cupcake left on the tray. So there's 7 vanilla, so vanilla, 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 1, 2, 3, 4, 5, 6, 7, and 2 chocolate, chocolate, chocolate. So, and we want to find the probability that there's at least 1 chocolate cupcake left on the tray after Ronan takes his 2. So let's consider what he can take. So Ronan could take a vanilla and a vanilla. If Ronan takes a vanilla and a vanilla, so if we find the probability of a vanilla and a vanilla, if he takes 2 vanillas, then that would leave 1, 2, 3, 4, 5 vanilla and 2 chocolate. And that would mean there's at least 1 chocolate cupcake left in the tray. Ronan could take 1 chocolate and 1 vanilla, because if he takes 1 chocolate and 1 vanilla, there's at least 1 chocolate left in the tray. So that means that Ronan could take a chocolate and a vanilla, or he could take a vanilla and a chocolate. So he could take a vanilla and vanilla, and that would leave 2 chocolate cupcakes on the tray. He could take a chocolate and a vanilla, that would leave 1, and we want to find the probability there's at least 1 chocolate left on the tray, 1 chocolate cupcake left on the tray. So a chocolate and a vanilla would work because there's at least 1 left, or a vanilla and then a chocolate because again there's at least 1 chocolate left. But Ronan couldn't take 2 chocolates. He couldn't take a chocolate cupcake and then another chocolate cupcake because then there'd be no chocolate cupcakes left in the tray. So we could do this question a couple of ways. We could do one approach is to work out the probability of a vanilla and a vanilla, a chocolate and a vanilla and chocolate, and then we could add all those up, and then that would tell us the probability of Ronan taking a vanilla and a vanilla, a chocolate and a vanilla, and vanilla and a chocolate, and all of those options would leave at least 1 chocolate cupcake on the tray. Or we could work out the probability that Ronan takes 2 chocolate cupcakes, so the one that doesn't work, and then take that away from 1, and then that'll give you the same answer. So I'm going to use this approach to begin with. So let's find the probability that Ronan takes a vanilla and vanilla. So actually let's put those other ones back in there. So let's just put that vanilla and that chocolate one back on the tray. Okay, so we've got a tray with 7 vanilla and 2 chocolate cupcakes. So the probability for vanilla and then another vanilla. So the first one being vanilla will be 7 out of 9, 7/9, because there's 7 vanilla cupcakes out of the 9 cupcakes altogether. Then we're going to take that one off the tray, and then the next one being vanilla will be 6 out of 8, 6/8, because there's 6 vanilla cupcakes left on the tray and there's 8 altogether, so 6/8. So if we do 7/9 times 6/8, that'll be the probability that Ronan takes a vanilla and then another vanilla cupcake off the tray. So 7/9 times 6/8 is a calculator question, and when I work that out in the calculator, I get an answer of 7/12. So the probability that Ronan takes 2 vanilla cupcakes is 7/12. Okay, chocolate and then vanilla. Okay, so let's put that vanilla one back in. So the first one being chocolate, well, that's going to be 2/9 because there's 2 chocolate out of the 9 cupcakes. Then one of the chocolates taken out, and the probability the next one being vanilla will be 7/8, 7 out of 8. And then if we work that out, 2/9 times 7/8, 2/9 times 7/8, that's equal to 7/36. So that's the probability that Ronan takes a chocolate and then a vanilla cupcake. And then finally a vanilla and then a chocolate. Well, let's put that chocolate one back in. The probability that the first cupcake is vanilla will be 7/9, so 7/9. And then we're going to multiply that. So if vanilla one's been taken out, then the probability the next one is chocolate will be 2 out of 8, so 2/8. And then if we work that out, 7/9 multiplied by 2/8, that's equal to 7/36. So that's fantastic. We've now worked out the probability of all the options that would leave one chocolate cupcake left on the tray. Okay, so if we add together these probabilities, we'll find the probability that there's at least one chocolate cupcake left in the tray. So if we do 7/12 plus 7/36 plus 7/36, that'll give us our answer. So let's do that. And that's equal to 35/36. So that means the probability that there's at least one chocolate cupcake left in the tray after Ronan takes 2 cupcakes would be 35/36. And that's it. Now, I did mention there was another way to do it, and rather than considering the probability that Ronan chooses 2 vanillas, a chocolate and a vanilla and a chocolate, and therefore leaving one chocolate cupcake on the tray, what we could do is we could find the outcomes that would mean that there was no chocolate cupcakes left in the tray, which would only be a chocolate and a chocolate. So if we do 1 take away the probability of a chocolate and a chocolate, that should also give us 35/36. So let's check that. So let's find the probability of a chocolate and a chocolate. So the probability that the first cupcake chosen at random would be chocolate would be 2/9, so 2/9, and we're going to multiply that by the probability that the second one would be chocolate, which would be 1/8. And if we do 2/9 times 1/8, that's equal to 1/36. And if we do 1 take away 1/36, that's equal to 35/36. And that's it. I really like this question. One thing we have to be really careful with this question is actually reading it and understanding what we're being asked. We're being asked to find the probability that there's at least one chocolate cupcake left in the tray. So we want to find the probability that Ronan takes a vanilla and a chocolate and a vanilla, or a vanilla and a chocolate. And that's it. Okay, let's look at our next question, question number 11. Okay, so question number 11, we've got this table, and we're told there's 50 students in year 11, and each student studies one language. So we've got French and German, and we've got female and male, and we're told that 2 students are selected at random. Calculate the probability that the 2 students study the same language. So we want to find the probability that the 2 students selected at random study the same language. So we want to find either the probability that they both study French, so French and French, or the probability that they both study German, so German and German. So let's find the probability that the 2 students selected at random both study French. So how many students study French altogether? Well, there's 13 females that study French and 5 males that study French. So altogether there's 18 students that study French. And in terms of German, if we do 15 plus 17, that's equal to 32. And what's fantastic there is that 18 plus 32 is equal to 50, so we know we've done that right. So we know that there's 18 students who study French. So the probability that one of these students selected at random studies French would be 18 out of 50, so 18/50ths. And then the next one, well, if that student's taken out of the group, we've got 49 students left, and 17 would then study French. So the probability that the second one studying French would be 17/49ths. And if we do 18/50ths times 17/49ths, that'll be the probability that the 2 students selected at random both study French. So let's work that out. And that's equal to 153 over 1,225. Okay, now the probability that they both study German. Well, there's 32 students that study German, so the probability that the first one selected at random out of the 50 studies German would be 32/50ths. Then that student's taken out of the group, and then the second one studying German, well, there'll be 31 left that study German out of the 49 students left. So if we do 32 over 50 times 31 out of 49, that'll again give us the probability that they both study German. So let's do that. 32/50ths multiplied by 31/49ths is equal to 496 out of 1,225. And then if we add those two together, that'll be the probability that the 2 students study the same language. So let's do that. And that's equal to 649 out of 1,225, or 649 is 1,225ths, and that's it. Okay, so let's have a look at our next question, question number 12. Now, question number 12 is a non-calculator question, so I'm putting down my calculator. And we're told that Samantha's got 10 black socks, 8 white socks, and 2 blue socks. And she's going to pick 2 socks at random without replacement. And we've been asked to find the probability that she chooses 2 socks of the same colour. So we've got black, white, and blue. So we want to find the probability of a black and a black. So black and black. We want to find the probability of white and white. So white and white. And we also want to find the probability of a blue and a blue. So we want to find those 3 possible outcomes and then add them together, and that'll be the probability that Samantha chooses 2 socks of the same colour. So let's work this out. So the probability of a black and a black, so a black and a black, the first sock being black, well, let's work how many socks there are all together. 10 plus 8 is 18, plus 2 is 20, there's 20 socks. And in terms of the 20 socks, 10 are black. So the probability that the first one selected at random would be black would be 10 out of 20, or I suppose 1/2, so 10 20ths. And then the second one being black, well, if 1 black sock's been taken out, there'd be 19 socks left, and there'd be 9 black socks left because obviously one of them's been taken out. So if we do 10 20ths multiplied by 9 19ths, that'll be the probability that 2 socks are black. So let's work that out. And when we work that out, now remember it's a non-calculator question, so 10 times 9 is 90, and 20 times 19 is equal to 380. So the probability of getting a black sock and another black sock would be 90 380ths. And we're obviously it's a non-calculator question, so we've had to work that out. Okay, next, the probability of a white sock and then another white sock. Well, there's 20 socks altogether, and there's 8 white, so the probability that the first sock selected at random as white would be 8 20ths. Then that sock's taken out, so there's 7 white socks left, and there's 19 socks altogether, so the probability that the second one is white would be 7 19ths. Then if we multiply those together, 8 times 7 is 56, and 20 times 19 is 380. So the probability that Samantha chooses 2 white socks would be 56 380ths. And then finally, the probability that Samantha chooses 2 blue socks, well, there's 20 socks and 2 of them are blue, so the probability that the first sock selected at random as blue would be 2 20ths. And then if one of those blue socks is taken away, that means there's 19 socks and one of them's blue, so the probability that the second sock is blue is 1/19. And then if we do 2 20ths times 1/19, we times the numerators, that'll be 2, and times the denominators, that's 380 again. And then that's fantastic. We've now found the probability of a black sock and a black sock, a white sock and a white sock, and a blue sock and a blue sock. And to find the probability that Samantha chooses 2 socks of the same colour, we just need to add together these probabilities. Now, it's fantastic is they've all got the same denominator because we didn't cancel them down, so it's going to be over 380. And let's add together the numerators. 90 plus 56 is 146, plus 2 would be 148. So the answer would be 148 380ths. And if you wanted to, you could cancel that down. You could half both of those to be 74 out of 190. That can be halved again to be 37 out of 95. And I think that's it. So you could give your answer in any of those forms. It doesn't say you have to cancel down your answer, so you could leave it as that, 148 380ths, or you could cancel it down to be 37 95ths. And that's it. Okay, let's look at our next question, question number 13. Okay, question number 13. We've got these discs that have got letters on them and they spell mathematics. And one disc is selected at random from the bag. The disc is not replaced, and then another disc is selected at random from the bag. So in other words, 2 discs are taken at random from the bag, but obviously one's taken out and then another one's taken out. So it's going to be a conditional probability question. And the question says, calculate the probability that exactly 1 M is taken from the bag. So we want to find the probability that exactly 1 M is selected from the bag. Now, rather than doing the probability of getting an M and an A, an M and a T, an M and an H, and so on, what I'm going to do is I'm going to treat it as finding the probability of getting an M, and then not an M, so not M, and also find the probability of getting not an M, so not an M, and then an M, because that will give us our answer if we find the probability of finding an M and then not an M, and then also the probability of getting not an M and then an M. We can add them together, and that'll be the probabilities of getting exactly 1 M from the bag. Okay, so let's consider this first of all, the probability of getting an M and then not an M. So in terms of an M, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 discs in the bag, and 2 of them have got M's on them. So the probability that the first disc selected at random from the bag has got an M on it would be 2 out of 11. So 2 11s. Then one of those M's is taken out, so we'll be then left with 10 discs, and we want to find the probability of getting not an M. So not an M, well, that's going to be either this one, 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 and this one. And so there's 10 discs that are left, and 9 of them do not have an M on it, so that'll be 9 tenths. Or another way to consider it is if you know there's 10 discs left and one of them's got an M on it, that means the other 9 don't. So the probability of getting an M and not an M would be 2/11 multiplied by 9 tenths. And then if we work that out, it's a calculator question, so I'm going to get my calculator here, and I'm going to do 2/11 multiplied by 9 tenths. And that's equal to 9/55, so 9/55. So that's fantastic. Now let's find the probability of getting not an M and then an M. So let's actually just put that M back in there, that one there. So not an M, so there's 11 discs and 2 of them have got M's on them and 9 of them don't. So not an M would be 9/11. Then one of the not an M's is taken out, so there's now only 10 discs left and 2 of them have got M's on it. So the probability that the second one's going to be an M would be 2/10, so 2 tenths. And then let's work that out. If we do 9/11 multiplied by 2 tenths, that's equal to 9/55 as well. And that's fantastic. We've now got the probability of getting an M and not an M, so exactly 1 M. And we've also got the probability of getting not an M and an M, also exactly 1 M. If we add those two probabilities together, that'll then tell us the probability of getting exactly 1 M from the bag. So if we add together 9/55 and 9/55, that's equal to 18/55. And that's it. So the probability that exactly 1 M is taken out of the bag would be 18/55. Okay, let's have a look at our next question. Question number 14. So question number 14 says that Jeremy has 2 bags of beads. In bag 1, it contains 7 blue beads and 3 yellow beads, and bag 2 contains 11 blue beads and 4 yellow beads. And Jeremy rolls a fair 6-sided dice. So he's got a fair 6-sided dice and he rolls that. If he rolls a number less than 3, so 1 or 2, he takes a bead from bag 1. And if he doesn't roll a number less than 3, so it's going to be the numbers that are not less than 3 would be 3 itself, 4, 5 or 6, he's going to take a bead from bag 2. And the question says, work out the probability that Jeremy chooses a yellow bead. Okay, so let's consider the outcomes that would give Jeremy a yellow bead. So first of all, he could get a number less than 3. So we're going to look for the probability of a less than 3 on the dice, and then a yellow bead. And we're also going to look at him getting a 3 or more, so 3 or more, so not less than 3, 3 or more, and a yellow bead as well. So they're the two possible outcomes, that he rolls a number less than 3, but then gets a yellow bead from bag 1, or he rolls a 3 or more, and then he gets a yellow bead from bag 2. So let's work this out. So in terms of getting a less than 3, so less than 3 on a dice, well that's a 1 or 2 out of 6, that'll be 2 out of 6, so 2/6. You could write 1/3 if you wanted to, but 2/6. Then the probability that he gets a yellow bead, because if he rolls a number that's less than 3, he then takes a bead from bag 1. So if we go to bag 1, in bag 1 there's 10 beads altogether, because there's 7 blue and 3 yellow, so there's 10 beads altogether. And the probability that he picks yellow will be 3 out of 10, 3 tenths. So what we're going to do is we're going to multiply 2/6 by 3 tenths, because the probability that he rolls a number less than 3 is 2/6. And then if he does that, he goes to bag 1 and he takes a bead out of that bag, and the probability that he gets a yellow will be 3 tenths, because it's 3 out of the 10. And then if we multiply those together, it's a calculator question, so let's do that. And that would be equal to 1/10. So the probability of Jeremy rolling a number that's less than a 3 and then getting a yellow bead from bag 1 would be 1/10. Okay, now let's look at the other option, that he rolls a 3 or more. So there's 1, 2, 3, 4 possible numbers on the dice that would work there. So the probability that he rolls a 3 or more will be 4/6. And then we're going to multiply that by, when he rolls that number that's not less than 3, so whenever he rolls a 3 or 4 or 5 or 6, he then picks a bead from bag 2. So let's go up to bag 2, and we want to find the probability that he picks a yellow bead from bag 2. In bag 2, there's 15 beads altogether, and 4 of them are yellow. So the probability that he picks a yellow bead from bag 2 would be 4/15. And then if we just times them together, and that'd be equal to 8/45. So the probability of Jeremy rolling a number that's not less than 3, so a 3 or 4 or 5 or 6, and then picks a yellow bead from bag 2 would be 8/45. And then if we add those two together, because it's either this option or this option, that'll tell us the probability of Jeremy choosing a yellow bead. So we're going to do 1/10 plus 8/45, and that's equal to 5/18. And that's it. So the probability of Jeremy choosing a yellow bead would be 5/18. Okay, let's have a look at our next question, question number 15. So question number 15 says it's 8 sweets in a bag, so it's 8 sweets in a bag, and 3 of them are red, 3 of them are blue, and 2 of them are green. So we've got a red, 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 blue, 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 green, and green.
And we're told that 3 sweets are selected at random without replacement. So 3 sweets are going to be taken out of this bag without replacement. So taking one out, then another one out, and then another one out without putting any back in. And we've been asked to calculate the probability that the sweets are not all the same colour. So that could be, for instance, a red, and a green, a red, and a blue, a red, and a green, and so on. And there's loads of possible outcomes there. So rather than considering all of those, what I'm actually going to do is I'm going to work out one, take away the probability that they're the same colour, because there's only a few options that could work in terms of them being the same colour, and that means that all the other options would have to be different colours. So that means that if we do one, take away the probability that they're the same colour, then that'll give us then the answer. So let's work out then the probabilities that they're the same colour. Now 3 sweets have been taken out of the bag, 3 sweets. So that means it wouldn't be possible to take 3 green sweets out of the bag. We can't take a green, and another green out of the bag because there's only 2 green sweets in the bag. So there's only 2 possible options that would work there for them being the same colour. We are going to find the probability of a red, and a red. And we're also going to find the probability of a blue, and a blue. And when we add them together, that'll tell us the probability that the sweets are the same colour. And then if we do one, take away that answer, then that'll be the probability that they're not all the same colour. So let's work these out. So the probability of a red, and a red. So if we've got these 8 sweets in a bag, the probability that the first one is a red is 3/8. So 3/8. Then if we take a red one out, the probability that the second one would be red would be 2/7. So 2/7. And then when that one comes out, then the probability that the last one is red would be 1/6. So 1/6. And then if we just times them together, that'll be the probability of getting 3 red sweets from the bag. So let's work this out. And that's equal to 1/56. So the probability of 3 red sweets being taken out of the bag without a replacement is 1/56. Okay, now let's have a look at the probability of taking 3 blue sweets from the bag. Now that's actually going to be the same, because if we look at it, there's 3 blue sweets as well. So the first one being blue would be 3/8. The probability of the first one being blue is 3/8. If it's taken out, the probability of the next one being blue is 2/7. And the last one being blue would then be 1/6. And if we times them all together, we would get 1/56 again. So the probability of getting 3 blues would be 1/56 as well. Then if we add these two together, if we do 1/56 plus 1/56, that's equal to 2/56, or 1/28, 1/28. And that's the probability that then the 3 sweets are the same colour. So that means that all the other options, all the other outcomes will be where the sweets are not the same colour. So if we do 1, take away 1/28, that'll then tell us the probability that the sweets are not all the same colour. And 1, which is 28/28, take away 1/28 would be 27/28. And that's it. So the probability that the sweets are not all the same colour would be 27/28. And that's it. Okay, let's have a look at our next question, question number 16. So question number 16 says, Thomas is playing tennis, and if it's windy, the probability that he serves an ace is 0.1. And if it's not windy, the probability that he serves an ace is 0.25. Probably because if it's not windy, he's a bit more accurate. That's why the probability that he serves an ace is higher. And the probability that it's windy is 0.3. Calculate the probability that Thomas serves an ace. Now this question actually lends itself quite nicely to a tree diagram. You could do a tree diagram here with windy, not windy, and then ace, no ace, no ace if you wanted to. In this video I'm going to do these questions a lot of the time without a tree diagram, so let's do it that way. So we're going to look at the probability that it is windy and that he serves an ace, and then the probability that it's not windy and he serves an ace, so not windy and serves an ace. So let's do that. Okay, so in terms of windy and ace, so the probability that it's windy is 0.3, so it's going to be 0.3, multiplied by, then the probability that he gets an ace if it's windy is 0.1. So if we do 0.3 times 0.1, that'll tell us the probability that it's going to be windy and that Thomas serves an ace. And if you think of your tree diagram, that makes sense, because you would do windy, which is 0.3, and then ace, 0.1, and you times those together. And 0.3 times 0.1 is 0.03. Okay, the probability of it not being windy and Thomas serving an ace. So not windy, well, if it's windy, the probability that it's windy is 0.3. The probability it's not windy would be 0.7. And then we're going to times that by the probability that he serves an ace when it's not windy, which is 0.25. So if we do 0.7 times 0.25, that'll be the answer to that. So 0.7 times 0.25 is equal to 0.175. So that's fantastic. We now know the probability that it's windy and Thomas serves an ace, and then the probability that it's not windy and Thomas serves an ace. So if we want to find the probability that Thomas serves an ace, we just need to add these two probabilities together. So let's do 0.175 plus 0.03, and that's equal to, if we add those two together, we get an answer of 0.205. And that's it. So that's the probability that Thomas serves an ace, 0.205. Okay, let's have a look at our next question, question number 17. So question number 17 says, Jenny and Penny are identical twins, and they're in the same mathematics class, which is a total of 20 students. So there's Jenny, Penny, and 18 other students. And the teacher's going to select 2 students at random to go on a trip. So the teacher's going to pick 2 of the students at random to go on a trip. And we've been asked to calculate the probability that at least one twin goes on the trip. So that could be Jenny and somebody else, Penny and somebody else, or Jenny and Penny. Actually, in terms of how they're selected, it could be Jenny and somebody else, or somebody else and Jenny, and so on. But in terms of this question, I think an easier way to do this question would actually be to do 1, take away the probability of no twin. Because if we do 1, take away the probability of no twin, well then that'll leave the probability that at least one twin goes on the trip, or both. So let's find the probability of no twin being selected, no twin being selected. So that means it'll be the probability of getting somebody else and then somebody else. So let's find the probability that somebody else is selected to begin with. So we've got Jenny, Penny, and there's 20 students altogether. So that means there's going to be 18 other students. So the probability that somebody else is picked to begin with would be 18 out of 20. It'd be one of those over 18 students, and then it would be out of the 20 students altogether. So that's the probability that somebody else is picked, 18/20. Then, if somebody else has been picked, well then there'll be Jenny, Penny, and then 17 other students in the class. So the probability that the second person picked at random won't be one of these 2 people, will be 17 out of 19, because obviously there's now 19 people to pick from, and there's 17 other people. So if we do 18/20 multiplied by 17/19, that'll tell us the probability that no twin is selected to go on the trip. So let's do that. So let's do 18/20, 18/20 multiplied by 17/19, and that's equal to 153 190ths. So that's the probability that no twin is selected to go on the trip. So that means the rest, which would be 37 190ths, would then be the probability that at least one twin goes on the trip. So let's do 1 subtract 153 190ths and see what we get. So 1 take away that answer is equal to 37 190ths. And that's it. That'll be the probability that at least one twin goes on the trip. And I just find that a bit of an easier way to do that question. 1 take away the probability of no twin being selected will give us the probability that at least one twin will be selected to go on the trip. Okay, let's look at our next question, question number 18. Okay, so question number 18, it says Martina has some coins. So she's got a 5p, a 5p, a 10p, a 20p, a 20p, a 20p, a 50p, and a £1 coin. And Martina has to pay 60p for a car park ticket. So she's got to pay 60p for a car parking ticket. And she's going to select 3 coins at random without replacement from her pocket. So she's going to pick 3 coins at random from her pocket and without replacement. And the question says, work out the probability that she's chosen the exact price of the ticket. So in other words, she selected 60p with the 3 coins. So let's consider how we can make 60p using 3 of these coins. So she's not going to use the pound, because that's obviously going to be straight away above 60p. It's not going to be like 5p, 5p, and a 10p, because that's only 20p. So Martina could pick a 20p, a 20p, and a 20p. So she could pick, let's find the probability of 20p, a 20p, and a 20p. That's one option, because they would be exactly 60p whenever she takes them out of her pocket. Another option could be, well, she could pick a 50p, a 5p, and a 5p. So we're going to find the probability of a 50p, a 5p, and a 5p. But remember, this could be in a different order. It could be the probability that she gets a 5p, a 50p, and then a 5p, or also the probability that she gets a 5p, a 5p, and a 50p. They would all give her 60p. It's just obviously in different orders. And then if we go back up, are there any other options? No, that's it. So they're the possible options in terms of the 3 coins. It could be a 20p, a 20p, and then a 20p, or it could be a 50p, then a 5p, and then a 5p, or a 5p, a 50p, and then a 5p, or a 5p, a 5p, and then a 50p. So let's work out these probabilities. So let's work out the probability of Martina getting a 20p, a 20p, and a 20p to begin with. So in terms of the coins, she's got 8 coins, and she's got 3 20p's. So the probability that the first coin picked at random as a 20p would be 3/8, because it's 3 out of the 8 coins. Then, if one of the 20p's has been taken out, the probability that the next coin is a 20p would be 2 out of 7, so 2/7. And then, if that other 20p has been taken out, then we've got 1 20p left, and there's 6 coins. So the probability that the last coin is a 20p would be 1/6. So that's fantastic. If we multiply these together, that'll tell us the probability that Martina picks 3 20p coins. And when we work that out, and it is a calculator question, I just type this into my calculator and I get an answer of 1/56. So that's the probability that Martina picks 3 20p coins. Okay, now let's have a look at a 50p, a 5p, and a 5p. Okay, so let's make sure we put those 20p's back in, this one and this one. Okay, so a 50p, a 5p, and a 5p. So the first coin being a 50p, well, there's one 50p coin out of the 8 coins, so that'll be 1 out of 8. And then multiply by, 50p's been picked out, a 5p. Well, there's 2 5p coins out of the 7 coins that are left, so that's going to be 2 sevenths. And then if that's taken out, there'll be one 5p coin left, so that'll be 1 out of 6. So we've got 1/8, because the probability that the first coin being selected as 50p is 1 out of 8. Then when that coin's taken out, there's 7 coins left, and there's 2 5p's, so the probability that the next one is a 5p would be 2 sevenths. And then whenever one of those 5p's is taken out, then there's only 6 coins left, and the probability that it being a 5p would be 1/6. And then if we work that out, we get an answer of 1/168. And again, remember, it's a calculator question, so I've just typed that into my calculator. Okay, now let's have a look at the next one. Okay, now we want to find the probability of a 5p, a 50p, and then a 5p. Okay, so 5p, well, there's 2 5p coins out of the 8 coins, so the probability that the first one being selected as a 5p would be 2/8. Then the next one being a 50p, well, there's 7 coins now, and there's only one 50p, so that'll be 1 7th. And then the last one being a 5p coin, well, there's now 6 coins left, and there's only one 5p left, so that'll be 1/6. And remember, it's a calculator question, so if we times them together, we get an answer of 1/168. Okay, and then finally, the probability of getting a 5p, a 5p, and a 50p. Well, there's 2 5p coins, and there's 8 altogether, so the probability of the first coin being selected at random as a 5p would be 2/8. Then, when one of those 5p coins is taken out, there'll be 7 coins left, and the next one being a 5p, well, there's only one of them, so the probability of the next coin being a 5p would be 1 7th. And then finally, the probability that the last one is a 50p, well, there's 6 coins, and one of them's a 50p, so it'll be 1/6. And then if we times them together, we get 1/168. So that's fantastic. We now know the probability of Martina picking 3 20p coins, of a 50p and 2 5p coins, a 5p, a 50p, and a 5p coin, and a 5p, a 5p, and a 50p coin. And then if we add them together, that'll be the probability of Martina picking the exact amount of money that she needs for a car parking ticket. And whenever we add up these probabilities, and remember, it's a calculator question, when we add these probabilities up, we get an answer of 1/28, or 1/20th. And that's it. So the probability of Martina picking the exact amount of money she needs for the car parking ticket is 1/20th. And that's it. Okay, let's have a look at our next question. So question number 19 says, Jamie has these coins. He's got 1, 2, 3, 4, 5 1p coins. He's got 3 2p coins, a 5p coin, and a 10p coin. And Jamie picks 2 coins at random without replacement. And we've been asked to find the probability that the first coin selected is worth more than the second coin selected. So what I'm going to do here is I'm actually going to write down the possible options. So the first coin selected is worth more than the second. So let's start off with a probability of a 10p and a 5p. Because obviously the first coin is worth more than the second coin. He could pick a 10p and a 2p, or he could pick a 10p and a 1p. So there are all the options with 10p first. Okay, so now if we then look at 5p, then that would be the probability of him picking a 5p and then a 2p, and also a 5p and a 1p, and finally there'd be the probability of a 2p and a 1p. So there are all the options where the first coin is worth more than the second coin. So a 10p and a 5, a 10p and a 2p, a 10p and a 1p, a 5p and a 2p, a 5p and a 1p, and a 2p and a 1p. They're all the options that would work. Okay, so let's look at the probability of Jimmy picking a 10p and then a 5p. So in terms of a 10p and a 5p, there's 10 coins, there's one 10p, so the probability that the first coin is a 10p would be 1/10. And then we're going to multiply that by the second coin being a 5p, so if the first coin taken out is a 10p, there'd be 9 coins left, and there's only one 5p, so that'll be 1/9. And if we do 1/10 times 1/9, that's equal to 1/90, or 1/90th. So that's the probability of Jimmy picking a 10p and then a 5p. Now let's have a look at a 10p and a 2p. So again, that'll be 1 out of 10, because there's one 10p out of the 10 coins, so 1/10, multiplied by. And then once that 10p is taken out, then the probability of the second coin being a 2p would be 3 out of 9. So it's going to be 3/9, so 3/9. And then 1/10 times 3/9 would be 3/90. And it's a calculator question, so you may have typed that into your calculator and you would have got 1/30. Okay, next, the probability of a 10p and then a 1p. So 10p again would be 1/10 for the first coin. And then once that coin is taken out, the probability that the second coin is a 1p would be 5/9. So 5/9. And then 1/10 times 5/9 would be 5/90. And again, that could be cancelled down to 1/18, but I'm just going to leave it as 5/90 for the moment. Okay, now, so we've done all the options with the 10p being the first coin. Now let's have a look at the options with the 5p being the first coin. So 5p and a 2p. Well, the probability, let's put that 10p back in. So the probability that the first coin is a 5p would be 1/10 because there's one 5p out of the 10 coins. And then once that 5p is taken out, the probability that the second coin is a 2p would be 3/9, so 3/9. And 1/10 times 3/9 would be 3/90, or 1/30. Next, the probability for 5p and then a 1p. So again, the 5p would be 1/10 because there's 10 coins and one 5p. Once that 5p is taken out, then the next coin being a 5p would be 5/9, so 5/9. And then 1 times 5 is equal to 5, and 10 times 9 is equal to 90, so that's 5/90. And that's the options with the 5p being the first coin. Okay, now let's have a look at our last option, which is the probability that Jamie chooses a 2p and then a 1p, because obviously a 2p is worth more than a 1p. So the probability that the first coin being selected as a 2p would be 3 out of 10, so 3/10. And then once the 2p has been selected, that would leave 9 coins. And we want to find the probability that the second coin is a 1p, so that would be 5/9, so 5/9. And if we do 3/10 times 5/9, let's multiply the numerators. 3 times 5 is 15, and 10 times 9 is equal to 90. So that's 15/90. Now again, you may have done these on your calculator, and that's fine. Now we're going to add these together because we want to find the probability that the first coin selected is worth more than the second coin selected. So that's all these options. So if we add together the probabilities, that'll give us our answer. So let's do 1/90 plus 3/90 plus 5/90 plus 3/90 plus 5/90 plus 15/90. And again, you could type this into your calculator. I'm just going to do it without a calculator for the moment because all those fractions have 90 on the denominator, so I'm just going to put 90 there. And then in terms of the numerators, 1 plus 3 is 4, plus 5 is 9, plus 3 is 12, plus 5 is 17, plus 15 would be 32, so that's 32/90. And we can divide both of those by 2, so that'll be 16/45. And that's our answer. So the probability that Jamie chooses a first coin that's worth more than the second coin would be 16/45. And that's it. Okay, let's look at our next question, question number 20. So question number 20 says there's 20 passengers on a flight from London to Paris. So it must be quite a small plane, or just not very many passengers on it. And we're told that 60% of the passengers are from England. So we can work that out. We could do 60% of 20. And actually, let's just do that. 10% would be 2. So 60% would be 12. So there's 12 passengers from England. And the rest are from France. So that'll be another 8. So there's 8 French passengers. And we're told that 4 passengers are chosen at random to complete a survey. And the question is calculate the probability that all 4 passengers are French. So we want to find the probability of a French, a French, a French, and a French person being selected for the survey. Okay, so in terms of the probability the first person being selected is from France, well, there's 20 passengers, 8 are from France, that's going to be 8/20. Then if one of those passengers is taken away, so one of those French passengers is taken away, there'll be 19 passengers left, so 19 passengers. And there was 8 from France to begin with, but if a first one chosen is from France, that'll leave 7, so that'll be 7/19. And then it'll be 6/18, and 5/17. And if we just multiply those probabilities together, that'll tell us the probability that all 4 passengers selected are from France. So let's work that out. And when we work that out, and it's a calculator question, we get an answer of 14/969. So that's 14/969. And that's it. That's our answer, 14/969. And that's it. Okay, let's look at our next question, question number 21. So question number 21 says, Kevin's got 2 bags, each containing 4 discs. And bag 1 contains 3 discs labelled with the number 2, as you can see, and 1 disc labelled 1. Bag 2, it contains 4 discs as well, 1 disc 1, 1 disc 2, and 2 discs were labelled with the number 3. And then we're told that Kevin chooses a disc at random from bag 1, so he's going to take a disc at random from this bag, and he's going to look at it. And if the disc is labelled a 1, he's going to put it into bag 2, but if it's labelled a 2, he's not going to put it into bag 2. And then Kevin's going to choose a disc at random from bag 2. He then adds together the numbers of the 2 discs that he selected to get a score. And the question says, find the probability that Kevin scores a 4. Okay, so in terms of Kevin getting a 4, he could get a 2 and a 2, so he could choose a 2 and a 2. He could choose a 1 and a 3. And there are all the possible options because he's got to take a disc from bag 1 to begin with, so he can only choose a 2 or a 1. So that means then he needs to get, then if he picks a 2, he has to get a 2 from bag 2, or if he picks a 1, he has to get a 3 from bag 2. So we need to find the probability of Kevin choosing a 2 and then a 2, or the probability that he chooses a 1 and then a 3. Okay, so let's start off with the probability that Kevin chooses a 2 and then another 2. So the probability of a 2 and then a 2. Okay, so in terms of the probability of Kevin choosing a 2 from bag 1, so he just chooses one of these discs at random. There's 4 discs, 3 of them are labelled with the number 2, so the probability that he chooses a 2 is 3/4, 3 out of 4, so 3/4. Okay, then we're going to multiply that by the probability that he chooses a 2 from bag 2. Now let's just make sure we've read this properly. So if Kevin chooses a 2 from bag 1, he does not put it into bag 2. So he's just going to take, once he looks at this disc and sees it's a 2, he's then just going to choose one of these discs at random. So the probability that he chooses a 2 from this bag will be 1 out of 4, 1/4, because there's one disc labelled with a 2 out of the 4 discs, so 1/4. And then if we times them together, 3/4 times a quarter, 3 times 1 is equal to 3, and 4 times 4 is equal to 16. So the probability that Kevin chooses a 2 and then a 2 is equal to 3/16. And those two numbers, 2 and 2, would add together to be 4. Okay, now let's have a look at the probability that Kevin chooses a 1 and then a 3. Okay, so in terms of bag 1, he goes along to that bag, he chooses a disc at random, and we want to find the probability that he picks a 1. Well, it's going to be 1 out of 4, 1/4, because there's one disc with a 1 labelled on it, and there's 4 discs altogether, so that's a quarter. And then we're going to times that by. Now, if he chooses this disc with a 1 on it, he then puts this disc into bag 2 before he then chooses a disc from random from this bag. So if he takes this 1 out, he's going to look at it, see it's a 1, and then he's going to put it into this bag here. So this bag now would have 5 discs in it. And if we want to find the probability that he picks a 3 from this bag, well, let's have a look at the counters. There's 5 counters in the bag, and there's 2 of them labelled with a 3. So the probability that Kevin chooses a 3 from this bag is equal to 2/5. And then if we want to find the probability that Kevin chooses a 1 from this bag and then a 3 from this bag, we're just going to do a quarter times 2/5, and a quarter times 2/5 will be equal to 2/20, or 1/10. And now we just need to add these two probabilities together, because these are the two possible outcomes that would give us a 4 when the two numbers are added together, a 2 and a 2, or a 1 and a 3. So if we do 3/16 plus 2/20, and it's a calculator question, so we can just do this on the calculator and see what we get. So 3/16 plus 2/20 is equal to 23/80. So the probability that Kevin gets a 4 is equal to 23/80, and that's it. Okay, let's have a look at our next question, question number 22. So question number 22 says, Rebecca has 9 cards, each with a number written on it. And these are the 9 cards, 2, 2, 3, 4, 5, 6, 6, 7, and 9. She's going to pick 3 cards at random without replacement, so it's conditional probability. And she multiplies the 3 numbers together to get a score. And the question says, calculate the probability that the score is an even number. So in other words, whenever Rebecca takes the 3 cards from this pile, that whenever she multiplies those 3 numbers together, what's the probability that it's going to be an even answer at the end? Now, in terms of this, there's lots of ways of getting an even number whenever we do this, because it could be an even times an even times an even times an even times an even would be even and even times an odd, because if we do an even times an odd, that's an even, times an odd is even, so that'll be even. It could be an odd times an even times an odd. It could be an odd times an odd times an even. It could be an even times an even times an odd. It could be an even times an odd times an even, or it could even be an odd times an even times an even. And I think that's all the possible options there. However, there's only one way to get an odd answer. The only way to get an odd answer would be an odd times an odd times an odd. All 3 numbers would have to be odd in order for Rebecca to get an odd answer. So instead of doing all these probabilities, what I'm going to do is I'm going to find the probability that Rebecca gets an odd answer, and then if I do 1 take away that answer, that's then going to tell us the probability that she gets an even answer. So let's do that. So let's find the probability that Rebecca gets an odd number. So we're going to find the probability of an odd, and an odd, because if it's an odd number times an odd number times an odd number, then that'll be an odd answer. And that's the only way that Rebecca can get an odd answer. So if we find the probability that she gets an odd, we can do 1 take away that probability, and the answer will be the probability that she scores an even answer. Okay, so let's have a look at the cards. Let's count how many cards are even and how many cards are odd. So in terms of even, let's see how many even cards there are. There's 1, 2, 3, 4, 5. There's 5 even numbers. And in terms of the odd numbers, there's 1, 2, 3, 4. So that's fantastic. This is 4 odd numbers. So if we want to find the probability of Rebecca getting an odd, and then another odd, and then another odd, the probability that the first number is odd will be 4/9 because there's 9 cards and 4 of them are odd. Then that odd number is taken out, so one of the odd numbers is then taken out. That would leave 3 odds. So then the next one being odd would be 3/8, so 3/8. And the probably then the last one's odd would then be 2/7, so 2/7. And then if we times those probabilities together, that'll test the probability of Rebecca getting an odd score at the end, because that would be an odd, an odd, and an odd, and 3 odds times together is an odd answer. So let's do this on our calculator. 4/9 multiplied by 3/8 multiplied by 2/7, and that's equal to 1/21, 1/21. So that means the probability that Rebecca scores an odd score at the end when she multiplies the numbers together is 1/21. So if we do 1 subtract 1/21, that tells us the probability that she gets an even answer, because all the other options would have to be even. And 1, which is 21/21, take away 1/21 would be equal to 20/21. So the probability of Rebecca getting an even number is, whenever she multiplies those 3 numbers together, is 20/21. And that's it. Okay, let's have a look at our next question, question number 23. So question number 23 says there's n chocolates in a box, and 5 of the chocolates are dark chocolate and the rest are milk chocolate, and 2 chocolates are taken at random from the box. And the question, part A, says find the probability in terms of n that both are dark chocolates. Okay, so we're told there's n chocolates in the box and 5 of them are dark chocolate. So 5 of them are dark chocolate and the rest are milk chocolate. Now considering this n altogether, the number of milk chocolates would be n subtract 5. Because for instance, if there's 30 chocolates and 5 of them are dark chocolate, there'd be 25 milk chocolate, and because we would take the 5 away from the number of chocolates in the box. So if 5 of them are dark chocolate, n minus 5 must be the number of milk chocolates in the box. So if we go back to the question, we're told that 2 of the chocolates are taken at random from the box, and we want to find the probability that both of them are dark chocolate. So we want to find the probability of dark chocolate and dark chocolate. So in terms of the first chocolate, the probability that it's a dark chocolate would be, well, there's 5 dark chocolates in the box, that's 5, out of the number of chocolates, which would be n. Then we're going to times that by, well, one of those chocolates is going to come out of the box because we're taking a dark chocolate out of the box. So there won't be 5 anymore, there'll be 4. And there won't be n chocolates in the box, it'll be n minus 1 because there was n, one of them's been taken out, so there's now n minus 1. So the probability that the second chocolate is a dark chocolate would be 4 over n minus 1. And now if we want to find the probability, we just need to times these together. So 5 times 4 is equal to 20. And n times n minus 1, we could write it in brackets like this, n bracket n minus 1. And that's probably how I would leave it, like that, just n bracket n minus 1. Or you could expand that bracket to write it as 20 over n times n is n squared, and n times minus 1 would be minus n. So you could write it either way. I'd probably write it the top way. So I'd just write 20 over n bracket n minus 1. And that's it. Okay, let's have a look at our next part, part B. Part B says find the probability in terms of n that both of them are milk chocolate. So we want to find the probability of a milk chocolate and then another milk chocolate. So remember, in total there was n chocolates. 5 of them were dark chocolate and the rest were milk chocolate, which was n minus 5. The number of chocolates take away 5, they were the number of milk chocolates in the box, so milk chocolates. Okay, now we want to find the probability of a milk chocolate and then another milk chocolate. Okay, so in terms of the first one being milk chocolate, well, it's going to be the number of milk chocolates, which is n minus 5 over the total, so that's over n. That's the probability that the first chocolate is milk chocolate. Then we're going to times it by. So now, if we've taken out a milk chocolate out of the box, there won't be n anymore, it'll be n minus 1. And the number of milk chocolates will have gone down as well. So instead of it being n minus 5, there'll be one less, it'll be n minus 6. So the probability that the second chocolate is milk chocolate would be n minus 6 over the total number of chocolates, which is n minus 1. Now we just need to multiply these together. And I probably would just write it in with brackets. I would just write it as n minus 5 multiplied by n minus 6 over n bracket n minus 1. Just put them in brackets because that shows that we're multiplying them together. So the probability that both of the chocolates are milk chocolate would be n minus 5 multiplied by n minus 6 over n bracket n minus 1. And that's it. Okay, let's have a look at our next question, question number 24. Now, question number 24 is quite a lot of algebra involved in this question. Now, there may potentially be other approaches, but the approach that I use uses a lot of algebra. It might be quite useful for you to watch the videos in algebraic fractions, because that might be quite useful for you as well. So, Kira bakes vanilla and lemon cupcakes for a party, and there's 5 more vanilla than lemon cupcakes. Kira's going to pick 2 cupcakes at random, and the probability that she picks 2 cupcakes of the same colour is a half, and we've been asked to work out how many cupcakes Kira baked. Okay, so let's start off by looking at the question. So we know that Kira bakes vanilla and lemon cupcakes. Now, we're not told how many, but we are told that she makes 5 more vanilla than lemon cupcakes. Now, if you think back to forming algebraic expressions and forming equations, when you've got some information like this, it can be quite useful to use algebra. So we know there's 5 more vanilla cupcakes than lemon cupcakes. So I'm going to let the number of lemon cupcakes be x. And that means if there's 5 more vanilla, that means there'd be x plus 5 vanilla cupcakes, because there's 5 more of those. So we've let there be x lemon cupcakes, and that means there'd be x plus 5 vanilla cupcakes. And that means then that all together, because she bakes vanilla and lemon cupcakes, if we add those together, that'll be 2x plus 5. That's the total number of cupcakes that she's baked. Okay, and then we're told that Kira is going to pick 2 of the cupcakes at random, and the probability that she chooses 2 cupcakes of the same colour is a half. So that means the probability of a lemon and a lemon plus the probability of a vanilla and a vanilla would be equal to a half. And we want to find out what x is. So let's find expressions for the probability of Kira picking a lemon cupcake and another lemon cupcake. And let's also find an algebraic expression for the probability that she picks a vanilla cupcake and another vanilla cupcake. Let's add them together and then put it equal to a half. And then hopefully we'll be able to find out what x is. So let's do that. So let's find the probability of a lemon and another lemon. Okay, so in terms of the probability that the first cupcake is lemon, well, there's x lemon cupcakes, so x, out of the total number, which is 2x plus 5. So the probability that Kira picks a lemon cupcake to begin with would be x out of 2x plus 5. Then we're going to times that by. Now, one of the lemon cupcakes has been taken, so that means that instead of being x, it'd be x minus 1, there'd be 1 less. And the total will go down by 1 as well, so instead of it being 2x plus 5, it'll be 2x plus 4. And then if we times these together, that'll be the probability that Kira picks a lemon cupcake and another lemon cupcake. So let's times them together. X times x minus 1 would be x brackets x minus 1. And in terms of the denominator, it would be 2x plus 5 multiplied by 2x plus 4. Now, I haven't expanded that yet, but I've got a feeling in this question that we're going to need to do that. So that's the probability of Kira picking a lemon cupcake and a lemon cupcake. Now let's have a look at the probability that she picks a vanilla cupcake and a vanilla cupcake. So in terms of the first cupcake being vanilla, there was x plus 5 of those, so it's going to be x plus 5 out of the total, which is 2x plus 5. So that's the probability that the first cupcake picked at random is vanilla. And then we're going to times that by. Now we need to find the probability that if she takes a vanilla cupcake to begin with, what would the probability that the second one's vanilla? So instead of being x plus 5, it would now be x plus 4 because there's 1 less vanilla cupcake. And the total will go down by 1 as well, so it will go down to 2x plus 4 as we seen earlier. And then if we want to find the probability of a vanilla cupcake and another vanilla cupcake, we times those together, so that'll be, I'm just going to put it in brackets, x plus 5 times x plus 4 over 2x plus 5, and then in brackets 2x plus 4. So that's the probability of Kira picking a vanilla cupcake and another vanilla cupcake. Now we know that the probability that she picks 2 cupcakes of the same flavour is a half. So that means that this plus this is equal to a half. And that gives us a nice equation. Well, nice is a bit of a stretch. That gives us an equation we can solve. So let's write that down. So x bracket x minus 1 over 2x plus 5 multiplied by 2x plus 4. And then we're going to add, and then x plus 5, then brackets x plus 4. And then that's over the same denominator of 2x plus 5, brackets 2x plus 4. And when we add them together, that equals a half. Okay, so we've got this equation. So x times x minus 1 will be x squared minus x, just multiplying what's in the bracket by x. I'm going to leave the denominator for the moment. I'll expand it in a minute. It just saves me having to write out quite big denominators. And then plus, and then let's expand these brackets. X times x is x squared. X times 4 is 4x, and x times 5 would be 5x. Adding them together would be plus 9x. And then 5 times 4 is equal to 20, so plus 20. And again, that's over 2x plus 5, and then brackets 2x plus 4. And then when we add them together, that's equal to half. Okay, now let's add together the numerators. We've got x squared plus x squared would be 2x squared. We've got minus x plus 9x, that'll be plus 8x. And then we've got our plus 20. So we've added together the numerators, and then in terms of the denominators, because they've got the same denominators, that'll just be the same. But I'm actually going to do the expansion here, so I'm going to expand the denominator at this stage. But obviously it would be this, but I'm just expanding it. 2x times 2x is 4x squared. 2x times 4 is 8x, and 2x times 5 is 10x. Adding them together would be plus 18x, and 5 times 4 is 20, so plus 20. So we've just put it over that common denominator, but we've expanded the brackets there, and that equals a half. Okay, so this is fantastic. We're getting there. We're now going to solve this. One approach would be to times both sides of the equation by 4x squared plus 18x plus 20, and then multiply both sides of the equation by 2. If you've looked at cross multiplication, you can use cross multiplication. So in other words, this numerator times that denominator would be the same as that numerator times that denominator. And that's the approach I'm going to use. So let's do that. So this times 2. So this times 2 would be 2x squared times 2 would be 4x squared. 8x times 2 would be plus 16x, and 20 times 2 is plus 40. And that equals, well, 1 times this would just be this, so 4x squared plus 18x plus 20. Okay, now let's solve this equation. So I'm going to take 4x squared away from both sides, so they would just go. I'm going to take 16x away from both sides, so that would leave me on the left hand side 40, and is equal to, and taking 16x from this side would leave us with 2x plus 20, just taking away 16x's from both sides and the 4x squared away from both sides. Now I'm going to take 20 away from both sides, so if we do that, we're going to get on the left hand side 20 equals 2x. And then divide both sides by 2, we're going to get that x equals 10. So that's fantastic. We now know that x equals 10. So that means that x is equal to 10. So x is 10. That means there's 10 lemon cupcakes. There's 5 more, so there's 15 vanilla cupcakes. And the question is, how many cupcakes did she bake? Well, that's going to be 25, because there's 25 cupcakes altogether. So the answer is 25. And that's it. Okay, let's have a look at our next question, question number 25. So question number 25 says, Julie puts some white, yellow and green counters into an empty box, and the ratio of white to yellow to green counters is 2 to 2 to 1. It could be 2 white, 2 yellow and 1 green counter in the box. It could be 4 white, 4 yellow and 2 greens. It could be 6 white, 6 yellow and 3 greens, and so on. But we know that's the ratio, 2 to 2 to 1. And then we're told that Julie takes 2 counters at random from the box without replacement. And the probability that she takes 2 yellow counters is 1/7. And the question says, how many counters did Julie put into the box? Okay, so let's go back to the ratio. We know the ratio is 2 to 2 to 1. What I'm going to do is I'm going to say the number of white counters in the box is 2x. And I'm going to say the number of yellow counters in the box is 2x. And I'm going to say the number of green counters in the box is x. And the reason doing that is I don't actually know the number of white, yellow and green counters in the box, but I do know that they're in this ratio. So that means there's twice as many white counters than green counters and twice as many yellow counters than green counters. So 2x, 2x and x would be fantastic, because there could, for instance, if x was equal to 5, there could be 10 white, 10 yellow and 5 green and so on. Okay, now we were told the probability that she takes 2 yellow counters is 1/7. So let's find the probability of a yellow counter and a yellow counter. So in terms of the first counter being yellow, altogether there's 5x counters in the box, and 2x of them are yellow. So that means the probability that the first counter selected from the box at random is yellow would be 2x out of 5x. Now that can be cancelled down to be 2/5, and that makes sense, because if the ratio is 2 to 2 to 1, that means the probability of getting a yellow counter out of the box would be 2 out of 5, 2/5. So that's fantastic. We've now found the probability that the first counter is yellow is 2x out of 5x, or 2/5 if you cancel it down. Okay, and then we're going to multiply that by the probability that the second counter is yellow. Okay, now if one of the yellow counters is taken out of the box, there won't be 2x yellow counters anymore. It'll be 2x minus 1, because there's 1 less. And the total wouldn't be 5x anymore. It'd be 5x minus 1, because it's gone down by 1. So in terms of the second counter being yellow, well, that would be 2x minus 1, because that's how many yellow counters there are, out of the total, which is 5x minus 1. So that's fantastic. We've now found the probability of the first counter being yellow and the second counter being yellow. Okay, now we're going to multiply these together. I'm actually just going to cancel down this first fraction. It's actually 2/5, because we can divide both the numerator and denominator by x. And we're going to multiply that by 2x minus 1 over 5x minus 1. Okay, so if we multiply those together, let's see what we get. So let's multiply the numerators and multiply the denominators. 2x minus 1 times by 2 would be 4x minus 2. And in terms of the denominator, if we multiply 5x minus 1 by 5, we get 25x minus 5. So that's fantastic. We've now found the probability of getting 2 yellow counters from the box. But the question told us that the probability of getting 2 yellow counters from the box is 1/7. So let's put that equal to it. Let's put that expression equal to 1/7. So that gives us 4x minus 2 over 25x minus 5 is equal to 1/7. And now this is an equation that we can solve, and if we solve this, we'll find x. So to solve this, we could multiply both sides of this equation by 25x minus 5, and also both sides of the equation by 7. But I'm going to use cross multiplication, so this numerator times that denominator will be equal to this numerator times that denominator. So 4x minus 2 times by 7 would be 28x minus 14, and that's going to be equal to, and 25x minus 5 times 1 will be 25x minus 5. So this is fantastic. Now we just need to solve this equation. I'm going to take 25x's away from both sides of the equation. So on the left hand side we'll be left with 3x minus 14, and on the right hand side of the equation we'll be left with minus 5. Now we want to find out what x is, so let's get rid of this minus 14, so let's add 14 to both sides of the equation. So the left hand side would just be 3x, and on the right hand side we had minus 5, we're adding 14, that'll bring us up to 9. And then finally let's divide both sides of the equation by 3, so we get that x equals 3. So that's fantastic. We now know that x is equal to 3, so we can go back up here. And in terms of the number of counters, well, at the beginning, remember, we let the number of y counters be 2x. Well, if x is equal to 3, 2x would be equal to 6. The number of yellow counters to begin with was 2x, so 2 times 3 is equal to 6 yellow counters. And the number of green counters was equal to x, that'll be 3. So if we do 6 plus 6 plus 3, 6 plus 6 is 12, plus 3 is 15. So that means there was 15 counters in the box to begin with. So the question is, how many counters did Julie put in the box? The answer is 15, and that's it. Okay, and let's have a look at our last question, question number 26. So question number 26 says there's X apples in a crate and 4 of the apples are bad. And Fiona chooses 2 apples from the crate at random without replacement. So she's going to choose 2 apples from the crate without replacement. And the probability that she selects 2 bad apples is 1/11. And part A says prove that x squared minus x minus 132 equals 0. Okay, so let's have a look at this crate to begin with. There's X apples in the crate altogether, and 4 of them are bad. So we've obviously got bad apples and good apples. So the total number of apples in the crate is equal to X. The number of bad apples is equal to 4. So that means the number of good apples must be the rest of them. So if we do the total take away 4, well, X take away 4 would be X take away 4. And that makes sense. For instance, if there's 20 apples altogether and 4 of them are bad, that means it'd be 16 good ones, and so on. So that's fantastic. Okay, so we're told that Fiona chooses 2 apples at random from the crate without replacement. So she's going to take 2 apples from the crate, and the probability that she selects 2 bad apples is 1/11. Now you could do a tree diagram here if you wanted to, and do a tree diagram with good apple, bad apple, and so on. But I'm just going to find the probability of 2 bad apples, so the probability of a bad apple and another bad apple. So if we find the probability of a bad apple and another bad apple, we can then put that equal to 1/11. So let's do that. So let's start off by finding the probability that the first apple selected at random from the crate is bad. So altogether there's X apples in the crate and 4 of them are bad. So the probability that the first apple is bad would be 4/X, because there's X altogether and 4 of them are bad. So the probability that the first apple selected at random is bad would be 4/X. And then we're going to multiply that by, now one of the apples is coming out of the crate, a bad apple, because there's probably 2 bad apples. So one of the apples is coming out, one of the bad apples is coming out. So there won't be 4 in the crate anymore. There'll be 3 in the crate, 3 left in the crate. And the total, it won't be X anymore because we've taken an apple out. It's going to be X minus 1. So if we want to find the probability that the second apple is bad, it'll now be 3, because there's 3 bad apples, out of the total, which is X minus 1. And that's fantastic. So we can now multiply these together. 4 times 3 is equal to 12. And X times X minus 1, well, let's just write it in brackets, X bracket X minus 1. So that's fantastic. We've now found an expression for the probability of 2 bad apples. But we were told in the question that that's equal to 1/11. So let's put it equal to 1/11. So let's write 12 over X bracket X minus 1 is equal to 1/11, because that's what it tells us in the question. So here we've got a fraction equals a fraction, so we could multiply both sides of this equation by X bracket X minus 1, and also both sides of the equation by 11, but I'm going to use cross multiplication. So in other words, this numerator times that denominator equals that numerator times that denominator. So 12 times 11 is 132, that's fantastic, and that equals X bracket X minus 1 times 1, so that'll just be X bracket X minus 1. Okay, now we just need to expand this bracket and then bring everything over to one side. So if we expand the bracket, X times X is X squared, and X times minus 1 will be minus X, and then that still equals 132. And then if we take 132 away from both sides, we get that 0 is equal to X squared minus X minus 132. And that's it, we've proved what needs to be proven. Okay, now let's have a look at part B. And then part B asks us to find X, the number of apples in the crate. So if we go back up, remember, the total number of apples in the crate was X. So if we find X, that's the total number of apples in the crate. And we've got this equation. The equation is X squared minus X minus 132 is equal to 0. So if we solve this equation, we can find x. So bracket, 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 bracket equals 0. Hopefully it factorizes. X at the front of both brackets. And we now want to find two numbers that will times together to be minus 132, but add together to be negative 1, because that's minus x, which is minus 1x. And I'm thinking 12 and 11. I'm thinking minus 12, so minus 12 and plus 11. Because minus 12 times 11 is minus 132, and minus 12 plus 11 is negative 1. So that's it. So that means that either x will be equal to 12 or x would be equal to negative 11. Now there can't be negative 11 apples in the crate, so x must be equal to 12. So there must be 12 apples in the crate. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on conditional probability. If you need any extra help on this topic, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 247, there's a dedicated video tutorial there on conditional probability. Alternatively, you could scan this QR code. But in this video, we're focused on the video solutions to the practice questions. I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to my YouTube channel. Thank you. Cheers. Bye.